Okay, so now I'm going to show you an example of a combination. So yesterday, hopefully you got your mind wrapped around and were able to execute being able to find a permutation where the order does matter. So today, we're going to look at combination where the order does not matter. Okay, very, very similar to how, a lot of the same steps that we took to get the permutation, just kind of one little extra step here. So one example here, 6 students are running for 2 spots on the senior board committee. How many different combinations could there be? Okay, so I'm going to show you how to do this by hand first, and then at the end of this video, I'm going to show you a short and sweet kind of calculator hack to do this as well. Okay, so first you need to think about why this is a combination and not a permutation. Remember, a combination is the order does not matter. Okay, so we have 6 students running for 2 spots. So it really doesn't specify what spots they're in. It's just they're just part of a committee. Okay, so if we think about just picking 2 of the kids. If we have student 1 and student 2, does it matter if student 1 is in and then student 2, or does it matter that student 2 is in and then student 1? Okay, and the answer is no. It doesn't matter that student 1 was in first and then student 2, or student 2 was in first and then student 1. All that matters is student 1 and 2 is now on the committee. Okay, so yesterday we talked about, how to find the different combinations or the permutations for running a race. It did matter what horse finished first, what horse finished second, what horse finished third, right? So there, the order did matter, right? So we had to specify which came where. In a combination, you're looking for, does it matter if student 1 or student 2 comes in, or student 2 then student 1, right? And the answer is, here we're just looking to select kids for a committee. It doesn't matter what order they get in. It just matters that we need 2 people in the committee. Okay, so here is the formula that you might need to write down for our combinations. RNCR, and in this particular case, the N is how many total people, and R is how many are we choosing. So in this particular case, we have 6 students, and we want to know how many of those 6 students can have a combination of 2 spots. Okay, so then this is my N, this is my R. You have your formula, just kind of plug and chug. So now we've got 6 factorial divided by 2 factorial, parentheses N minus R, so we'll have 6 minus 2 factorial. Okay, so we've got parentheses here. We can kind of clean up that mess. So now we have 6 factorial over 2 factorial, 4 times 4 factorial. Okay, I know the first video I showed you, they go ahead and list out the 6 factorial, right, where it's 6 times 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 4 factorial is 4 times 3 times 2 times 1. Okay, so now that you've got both factorials listed out, I would definitely go through and see what I can cancel out. I think the video that I first showed you, the dude really canceled a lot out. You don't have to do that. Get a better look there. All right, so let's just see some of the basics here. The 1s really don't matter. I've got a 2 here. I've got a 3 here. I've got a 4 here. Again, the 1 doesn't matter. So, the guy kind of went into saying that 6 is the same thing as 2 times 3, so let's cancel the 2s. There's really not much left here, so I think you can kind of see what's going on here without simplifying and breaking down even more. Hopefully you have a calculator. So 6 times 5 is 30. 30 over 2 is 15. So there are 15 different combinations of 6 students when you're only choosing 2. Okay, so not too bad here. A lot of similarities dealing with the permutation. The hardest part is going to be able to distinguish, is this a combination or is it a permutation? And to be completely honest with you, I haven't dealt a lot with these until now. They even confuse me. reread the question 2, 3, 4 times before, if it takes you that much, it's okay. But the hardest part about this is determining, is this a permutation or is this a combination? The formula here, being able to kind of, substitute in and simplify, I don't think this is too terrible, especially after this calculator thing I'm about to show you. Just understand a permutation, it's more specific. The order does matter. It matters if you come in first, second, or third, or it matters if, maybe a kind of similar example to this, if you're trying to find the president and the vice president, okay? A combination, the order doesn't matter. In this particular case, we just wanted 2 spots in the committee, okay? So again, calculator hack. So here is the setup, right? You have 6 people for 2 spots. Let's get to our calculator here. Okay, so again, that math menu down the left-hand side. Let's turn the calculator on. So the math menu down the left-hand side, and again, on the far right tab there, we see PRB for probability. So let's go ahead and get to that tab. Hit enter. Oh, I didn't want to enter. We just need to get to it. So math, probability. So now we're in this menu. And again, yesterday we talked about how the second one down is a permutation. This one here, we need a combination, okay? So just like yesterday, we need to put the first number in before we get there. So it's a 6, okay? So we're picking 6 people, math, combination. So now it's acting as the N is my 6, which is what we want. The R is my 2. And let's hope this comes out to be a 15. And it is, right? So the N and R, which is exactly what our formula says, right? N choose R, okay? It's exactly what you're putting in your calculator. 6 choose 2 spots. And again, the math menu on the left-hand side, going over to the PRB, the probability tab in your calculator, and that second and third one down shows you the the permutation or the combination. Again, hardest part, you need to pick which one it actually is. Hope this helps.